So just like we saw with list comprehension, we can also perform a very similar operation for dictionaries and sets. So dictionary comprehension and set comprehension is just an elegant way to create new dictionaries or sets from an iterable in Python. Now, when creating a dictionary comprehension, it consists of an expression where we stipulate a key-value pair, followed by a for statement with the whole statement inside curly braces. So for example, if we were to create a dictionary using for loops, we could create a dictionary which shows numbers 0 to 5 as keys with the values as the key squared. So for example, if I create an empty dictionary, I could put squares, equals, and then put a set of curly braces. I could then put for x in range and then in brackets place 6. I can then put a colon. I can then create a dictionary key, so I could put squares to represent the dictionary, followed by square brackets, and then place x inside. So my keys will be 0 through to 5, and I can set this equal to x multiplied by x. In other words, take the square of each key. When I run this code and see what's stored inside squares, we can see that we get a key of 0 with the value 0, 1 with 1, 2 with 4, 3 with 9, and so on. Now we can get the same result by using dictionary comprehension. So how do you think this is performed? Well, let's start by creating our variable called squares, and we can set this equal to a set of empty curly braces. We can then, inside of these braces, put our key, so we can put x, colon, and then the expression for the value, which would be x multiplied by x, and we can then put our for statement. So we can then put for x in range, and inside parentheses, we can place 6. When I run this dictionary comprehension and then look inside the variable squares, you can see we get the same result as above, using a lot less syntax. And just like list comprehensions, dictionary comprehensions can also optionally contain more for or if statements if you so desire. So we might, for example, only want to see the squared numbers of even numbers only. So let's create a variable called even underscore squares, and we can then set this equal to a set of curly braces. Inside curly braces, we'll put x colon x multiplied by x as our expression, which gives us our key and value pair. We can then put our for statement, so we can put for x in range, and this time we'll go up to 10, so we'll put 11 inside parentheses. After our for statement, we can then include an if statement. So if we only wanted to see the even squares, we can put if x modulo 2 equals 0. When we run this code and take a look at what's stored in even underscore squares, you can see that we get an index of 0 with a value of 0, then 2 with a value of 4, 4 with 16, and so on. So our keys are only even values. Okay, so moving on, and hopefully unsurprisingly, we can do the same with sets. So let's quickly run through an example for completeness, and I'll first of all create a set called my underscore set, and inside curly braces, I can put the integers from 1 to 10. I will also then create an empty set, and I'll call this new underscore set, and I'll set this equal to an empty set which we know is created using the built-in set function. If we just use curly braces here, we would create a dictionary, so we do need to use the built-in set function. I will then put for x in my underscore set, and I will then add the square of each number to my empty set. So I can put new underscore set dot add, so we're using the add method on the set, and inside parentheses, I'll pass in x times x. So just to show you what each set contains at this point, I'll print out my underscore set contains, I'll then put curly braces. I can then use the dot format method and put my underscore set inside parentheses. I will also print out new underscore set contains, and then I'll put a set of curly braces, and we'll also then put dot format, and inside parentheses, we'll put new underscore set. When I run this, you can see that our original set contains integers 1 to 10, and our new set contains the squared numbers of our original set. Also remember that our set is unordered, so don't be surprised if you see an ordering which looks a bit strange. Now I can also perform the exact same thing here using set comprehension. So let's first of all copy our above code and paste it beneath. I will leave my_set as it is, but this time I'm going to change new_set to equal a set comprehension. So I'm going to put curly braces just like we would if we were trying to create a dictionary using dictionary comprehension, but this time rather than stipulating a key value pair, I'm going to put x multiplied by x for x in my_set. When I now run this code, you'll see we get the same result as above, once again using a lot less code for the set comprehension. So in the last video we saw list comprehensions, we've now seen dictionary comprehension and set comprehension, and it's a way of being able to create these data structures in a more elegant way, utilizing an expression followed by a for statement and then an optional if statement if you so desire. Practice each of these to make sure you understand how they operate. Once again, some people do prefer the longer way of creating these just using for loops because comprehension can sometimes be a little bit confusing to the eye, but it's important to showcase this to you because you will potentially come across this syntax in other code that you observe or contribute to, so it's definitely worth having it in your toolbox.